Good day everyone. Today we will have a hands-on exercises on the ANOVA tests and the Kruskal-Wallis H tests. So first is the hands-on on the ANOVA tests with the problem. In this experiment, 18 cocaine addicts were randomly assigned to one of three groups of 6 addicts per group. All groups received counseling over the 10-week treatment period plus the treatments. The experiments wanted to determine if there are significant differences between the number of cocaine urges by the participants assigned in the three groups. So here we can see that on the right side we have the data for treatment 1, acupuncture plus counseling. We name it as AC. Then placebo plus counseling, PC. And relaxation therapy plus counseling, RTC. So the data is here. So we're going to encode the data to Microsoft Excel. So actually I have already encoded the data to Microsoft Excel. And here are the columns for the scores. And this is for the treatment. So you can see that there are AC 6, PC 6 also, and the RTC is 6. Now we're going to save it as CSV file. Name ANOVA test, CSV, comma, delimited, and we name it as ANOVA test. So now we will use JASP to treat data. Okay, let us open first the file ANOVA test. Open. So here is our data. So we use ANOVA for the analysis. Yeah. So we will add also descriptives here. And we will also add some assumption checks like the homogeneity and also the post hoc test. So we will add the post hoc test there so that we can see which one has the difference or the significant difference later, because there are three comparisons of variables. So now we can see here in the ANOVA tests that there is a significant difference because the p-value is equivalent to 0.003, which is less than our alpha 0.005. Okay, and we can see also that on the data on the post hoc tests, we can see that in between AC or acupuncture and medicine, or acupuncture and counseling. So acupuncture and counseling and the placebo plus counseling has significant difference because the P2K is equivalent to 0.004. At the same time, the acupuncture plus counseling and RTC, or the relaxation therapy plus counseling, has 0.016 as its P2K, meaning there is a significant difference between AC and RTC. But on the last one, the PC, or the placebo plus counseling and relaxation therapy plus counseling has no significant difference because we can see that the P2K is 0.786. On this case also, we can see that the AC and PC has greater significance or higher significance between AC and RTC based on the P2K. So the probability value in the ANOVA test of cocaine addicts who are assigned to one of the three groups is less than 0.5. Therefore, there is a significant difference between the three groups of cocaine addicts. Based on the post hoc P2K, there is a significant difference between acupuncture and counseling and placebo and counseling. Also, there is a significant difference between acupuncture plus counseling and relaxation therapy plus counseling. And lastly, there is no significant difference between placebo plus counseling and relaxation therapy plus counseling. So in an APA format, we can say that there was a statistically significant difference between groups as demonstrated by one-way ANOVA. F, where F is 2 and 15 is equivalent to 843, with P is equivalent to 0.002. P2K post hoc test showed that the cocaine addicts who are assigned to acupuncture plus counseling AC and placebo plus counseling PC was able to obtain significantly higher test scores than those under group acupunctures plus counseling AC and relaxation therapy plus counseling RPC, where P is equivalent to 0.003. There was no statistically significant difference between the test scores of the cocaine addicts who are assigned to placebo plus counseling or PC groups, where P is equivalent to 0.78. Our second hands-on test today is the use of Kruskal-Wallis H tests. So our problem is an instructor conducts an experiment to evaluate if there is a significant difference in the three exam versions in terms of difficulty. The results are given in the table at the right side. So here we have a table which depicts three versions of exam. Exam version 1, exam version 2, and exam version 3. So these data actually are already encoded in Microsoft Excel. So let us look at it. And we will use JASP to analyze the data. So here is the data for the Kruskal-Wallis test, and we will save it as CSV file. Yeah. So we will name it as Kruskal-Wallis H test. Now we go to the JASP software or application and open the data. So Kruskal-Wallis H test. So here's the data, and we will go to ANOVA there and click ANOVA. Then add this one to the dependent variables and this one for the fixed factors. And we have the p-value, which is 0.793, and it has some descriptives. Yeah, that is for ANOVA. But what we need here is the non-parametrics, which is the Kruskal-Wallis. So we can see that the p-value of the Kruskal-Wallis test is 0.630, which means that there is no significant difference between the three examinations that was conducted. So here, the exam version 1, exam version 2, and exam version 3 results has no significant difference. And the probability value in the Kruskal-Wallis tests of the three exam versions in terms of difficulty is greater than 0.05. Therefore, there is no significant difference between the three exam versions in terms of difficulty. In an APA format, a Kruskal-Wallis H test showed that there was no statistical difference in the three exam versions in terms of difficulty, where X2 is 2 is equivalent to 0.923, and with the mean difficulty score of 84.5 for exam 1 and 81.2 for exam 2 and 83.6 for exam 3. Thank you and good day.